Let's do this problem right here. The question is asking if R4 R3 be the function given by fx1 x2 x3 x4, and first question is asking find the matrix A for which f of x equal to ax. So let's see how we can find it. So first of all, I would like to bring this in a matrix pattern. So this is what we have to find. So we know the matrix pattern is ax is equal to b. So in this case, we don't know the A, that's what the question is. And we know X is going to be this X1, X2, X3, X4. X1, X2, X3, X4. And this is 1 by 3 matrix. No. It's 4 by 1 matrix. And then this is equal to X1 plus X2. Then we have X3. Then the third one is X4. So this is 3 by 1 matrix. So the matrix we are going to get is 3 by 4. 3 by 4 matrix is that's what it's going to be here, because when we multiply both of them we are getting 3 by 1, right? So that's how we assume. And then first of all I have to see which value if I multiply give us x1 plus x2. For example, 1. So first, always our first column multiply the first thing, and therefore x1 to x6, and therefore this is also going to be 1 because this multiply x2 and we have an x2. Others are going to be 0 because we don't have anything others in the first column. And the second column we have only x3, so third value is going to be 1. So third value is going to be 1. And the third column we have x4, so fourth column is going to be 1. So this is how we find the A. So therefore my answer for the question is the matrix A is going to be 1 1 0 0 0 0 1 0 and 0 0 0 1. And this is the A question. Let's do the B question. What is the dimension of the range of F? So basically what are they asking is what is the dimension of column space. So range is basically the column space. So range of F is equal to this the columns with leading coefficient. So we have 1 0 0 0 1 0 0 0 1 1 0 0 0 1 0 and 0 0 1. So we have 3 vectors in the column space, therefore the dimension is equal to 3. And you can also say it with the leading coefficient, leading one. Then the C part is asking what is the dimension of kernel of F. Kernel means null space. So in this case I have to set this into null space, this one. So null space is basically a power a times x is equal to 0. And if I solve this one, 1 1 0 0 0 0 1 0 0 0 0 1, and if I set this one into 0, we know this is our free variable because the first column has leading one, third column has leading one, fourth column has leading one, but the second column doesn't have leading one. So that's a free variable. Therefore we have to give every answer in terms of x2. So let's do this one. And from now I can say that dimension is equal to 1 because the null space of dimension of null space depends on the free variable. So it's just going to be 1. But however, I'm just gonna put all the vectors of null space. So let's solve this equation. So it's going to be x1 plus x2 is equal to 0. Therefore x1 is equal to minus x2. Then the x2 is equal to x2 is, so x3 is 0, x3 is 0, then we can now directly write the answer. So we have x1 is going to be minus x2, x2 is going to be itself, x3 is going to be 0 because it doesn't have any x2, x4 is also 0. Therefore, if I take x2 common, it is going to be minus 1, 1, 0, 0. So this is the vector of null space, and we know the only vector is 1 because we have only one free variable. Therefore, dimension is equal to 1, and that's how it's done. I hope you guys like this video. See you next time.